A 4-chain leak, a medical physicist writing inference code for fun, and a memory architecture designed originally for video editors started one of the most important shifts in AI in the past years. For a while, it looked like AI was only moving in one direction: bigger models, bigger data centers, expensive subscriptions, and more dependency on 3 or 4 companies from California. But behind the scenes, something else was happening. A bunch of obsessed researchers and engineers were building a different kind of AI. Meanwhile, unified memory gave consumers the bandwidth these models actually need to run on their PCs, and all of this led to the rise of local AI. In this video, you'll learn how it all started, what you actually need to run local AI, and why it matters now more than ever as we enter the era of personalized agents and the end of subsidized subscriptions. Finally, I'm putting the current local kings, Qwen3.6 and Gemma 4, up against frontier intelligence to see how close local AI actually is. Timestamps are below. So let's go all the way back to 24th of February 2023 when Meta releases Llama, their state-of-the-art LLM to approved institutions and government agencies. And what follows after that is an absolutely incredible story, and like many incredible stories, it begins in the worst possible place, 4chan. The government in turn, I would assume, leaked the weights of Llama on 3rd of March 2023. The same day, Christopher King 42 makes a PR to Meta's official Llama repository with the legendary title "Save bandwidth by using a torrent to distribute more efficiently," providing a BitTorrent link to the leaked weights, and the community goes absolutely wild. And at this point, it's time to introduce you to Georgi, a medical physicist working for a radiation oncology company at the time, writing software to target cancer with lasers. 6 months before Llama leaked, he had been building a tensor library in pure C called GGML and used it to port OpenAI's Whisper speech model to ordinary CPUs without GPU required. In his own words, GGML was an attempt to write something in C like real men do. Basically, he was the guy she was telling you not to worry about. So when Llama leaked, he had the math, the tools, and a working pattern for a similar model architecture already in place. At that moment, Georgi was the most prepared person in the world for the job, and he took it. On March 10th, exactly 7 days after the leak, Georgi pushed the first commit of llama.cpp to GitHub, and the README literally said, "Hacked in an evening, I have no idea if it works correctly." Spoiler, it did work correctly. He's done 2 things in that single evening that nobody else had done yet. He'd written a from-scratch inference engine in pure C++ that run the math on consumer CPUs, and he shipped 4-bit quantization that shrunk the model from 13 GB to about 4 GB. Together, those 2 tricks meant you could run Llama on a MacBook, and within days, people had it running on phones and even on a Raspberry Pi. Now that we know how it all started, let's get a bit more practical. So feel free to skip this section if you already know the tools. There are 3 main options to run your own local AI, all of which use llama.cpp as its inference engine, which Georgi originally wrote. I won't go too deep here as these tools are usually easy to understand when you play with them a bit, but at least I'd like to give you an overview of the ecosystem along with some recommendations. The first option is LM Studio. It's a desktop app where you can browse and run local models. It comes with visual settings for everything you need: temperature, context length, sampling, and a chat user interface with conversation history. If you don't know what all these parameters mean, you can just keep the defaults. In its simplest form, it is somewhat close to ChatGPT, but local and with more settings. Basically, you don't have to touch the terminal. There's a great pre-selection of models, and if that's not enough, you can load any model directly from Hugging Face, which gives you a huge freedom, but also more ways to break things. Llama is the next alternative, which is headless first. It means that most people run it in a terminal as a background daemon, and you can install it on a server, Raspberry Pi, basically anything without a screen. It's faster and more efficient than LM Studio on lower-end hardware, and it's also open source. You can easily connect Llama to your OpenClaw or any of the popular coding harnesses, which I'll be doing during my testing later. It also recently added the user interface, though LM Studio is a better UI. The third and last option is running llama.cpp directly. You get maximum control like GPU layers, batch size, KV cache quantization, and every weird flag you probably shouldn't touch unless you know why it exists, but hey, I'm not judging. And because new architectures and formats often land here first, llama.cpp is usually for people who want to live on the bleeding edge. So next, I spent some time testing Qwen3.6 and Gemma 4 to answer one question: are local models finally good enough for real work? Of course, we can look at the artificial analysis benchmarks and get a rough idea of where the models stand, but I want to understand how these models actually feel, what quirks they have, are they in fact usable? And I was running the dense version of both Gemma 4 and Qwen at the full 256K context window with 8-bit quantization, which basically means each model weight is stored in 8 bits instead of 16 in order to trade a tiny amount of quality for half the memory. And just for context here, traditionally running a model that needs lots of VRAM on NVIDIA meant stacking GPUs, and those are really expensive. Apple Silicon changed that. It shares one big pool of memory between CPU and GPU, so 120 gigs of RAM is also 128 gigs of VRAM. And this is called unified memory. It was built to try to make Final Cut Pro exports less painful, but it just happens to be exactly what LMs need. Lots of memory and high bandwidth in one place. Therefore, Apple devices have been really popular in the local AI community. Now, if you're wondering what hardware you actually need to run local AI models, I have prepared a small table. Feel free to pause the video and have a look. But overall, a Mac Studio with 128 gigs of RAM is the best value for money, and if you want NVIDIA software stack, then the DGX Spark may be a good option. It's also smart to look for used hardware. My MacBook only has 24 gigs of RAM, which is not enough, so I rented a GPU to test the models. Before I get into the tests, here's how I'd characterize both models after spending some time with them. Qwen3.6 is generally smart, finds the right traces, asks the right questions, and then talks itself out of the answer and essentially apologizes to the bug. Watching its chain of thought is like watching a sharp, anxious junior engineer second-guessing themselves into a failure. Now, on the front-end side, Qwen3.6 is really good. Might as well be Opus behind the scenes as far as I'm concerned. Gemma 4 has the opposite problem. It's kind of dumb and really confident at the same time. Gemma 4 is the king of gaslighting. It will hallucinate a clean, well-structured, completely wrong answer and tell you it's sure, which might be why so many people online think it's better than it actually is. Now let me show you what I mean. Starting off with vision, I was surprised how good these models actually are. Both were able to read two very low quality pictures that I myself had hard time reading. Gemma 4 did a lot of reasoning and took a couple of minutes to complete the tasks. However, when running the Pi harness with a smaller context window, it did lie into my face in the most professionally formatted way possible. It said, "The text is surprisingly readable." The text was in fact not readable, and proceeded to tell me something that was not in the text at all. Qwen3.6 on the other hand was really quick to figure out what's on both images and gave me the answer within seconds. No long chain of thoughts, just straight to the point. Was really impressive. Next up was the backend reasoning, where I told Codex to fork the Pi coding agent source code and plant 3 bugs with increasing complexity. I started off with Opus 4.7 to set the baseline, which found all the bugs in 8 minutes, and Codex rated its effort 88 out of 100. Then I also tested Haiku 4.5, which was quite fast. Took only 4 minutes, but was only able to find the first bug, which it counted twice. Next up, I tried Gemini 3 Flash, which according to the benchmarks is just a little bit smarter than Qwen3.6. Gemini 3 Flash was stronger than expected. Caught 2 bugs. Then I tested Qwen3.6. I expected to be fast given how fast it solved the vision challenge, but it actually took 40 minutes and was longing for emotional support. And looking at its chain of thought, it seemed like someone who is super smart and super insecure at the same time. It spotted the third bug, described the consequence, then said not really a bug, and continued spinning in circles for half an hour and going again in the wrong direction. Second place was taken by Sonnet 4.6. Place number 5 is taken by Gemma 4. It had the opposite problem of Qwen3.6. Gemma 4 was kind of dumb and really confident at the same time, which, as I said, may also explain why many people think it's so good. It's actually not, it's just very confident. I did quite a bit of front-end testing as well, and although there was a clear winner here, there's a good chance things will start shifting later in the video. On the first challenge, which was about creating a magazine page, Gemma 4's attempt was readable, but the composition was a bit blunt, and the hero text was overlapping. So basically, Gemma built a magazine you'd never open twice. Qwen3.6 on the other hand was much more convincing. The type hierarchy is better and the design feels more intentional with a smooth refresh animation. The second challenge was much more about motion interaction, where Gemma 4 fell short again, and the result was kind of shallow, while Qwen3.6 design was much richer. The atmosphere is stronger, proper lights all over. The knobs were much more realistic with depth. I liked it. For the third challenge, I asked them to create an operations dashboard for a shipping logistics company. And to be honest, none of them did really well here, although Qwen had the edge in being less worse. And finally, the famous SVG challenge, Simon Willison's benchmark, where you ask a model to draw a pelican riding a bicycle. GPT 5.5 and Opus 4.7 against Gemma 4 and Qwen 3.6. Conclusion: Qwen 3.6 is clearly ahead of Gemma on frontend and better than I expected. Also, Qwen gives me Opus vibes, make of that what you will, and Gemma gives me Gemini vibes, which makes a lot of sense. For math, I gave them 3 problems increasing in difficulty. Across multiple runs, both Gemma and Qwen repeatedly found the correct answer. It was interesting to see that for some runs they used math reasoning, and other times they actually wrote code to solve the most difficult problem. Out of 6 runs, Qwen did fail once though, while Gemma didn't. It was really impressive, especially since Gemini 3 Flash failed on the most difficult problem here. Lastly, I want to talk a bit about writing and personality. Gemma is clean, polished, and more formal, but when it comes to writing YouTube scripts, for example, it feels overtrained on hype videos because that's the kind of data Google has, but it does provide better structure and pacing. Qwen feels like it has more taste, again with a bit of that Opus flavor in it. It's more emotional and less mechanical than Gemma. All to say that I like Qwen's writing and personality a bit more, and when I think about it, I even like it more than GPT. So here's where I land on Qwen and Gemma after all this testing. On the intelligence timeline, we are somewhere between Opus 4 and Opus 4.5, and remember, Opus 4.5 was the breakpoint where AI became genuinely usable. Right now, local AI can already handle a lot of boring stuff: extract this, summarize that, refactor a file, write an email, but probably not more than this. Frontier is still ahead on the hard stuff. You saw it. Opus found all the bugs in 8 minutes, Qwen took 40 and didn't fully solve the problem. The gap will shrink, but it's not going away. However, a year or 2 from now, I expect it will be running much more complex tasks locally, maybe even shifting 80% of our AI work onto local models. And one more thing I want to mention, the setup is still not super user-friendly. Llama is great, but if you've never opened a terminal, you're going to have a hard time. Now, with the rise of local AI agents, it's even more important to start thinking about the hybrid future, where we are running 80% of the tasks locally and sending the hard 20% to the frontier. Right now, a lot of people are using AI agents like Hermes or OpenClaw for business use cases, but the builds are getting pretty expensive. It's hard to justify them, and a lot of folks are actually being priced out. And it's about to get worse, by the way. Frontier tokens are cheaper right now because they are subsidized. Every lab is trying to get market share, but when the subsidy ends, the workflows you built on cheap tokens get suddenly very expensive. So hybrid is a fix. Anthropic literally shipped this as a first-party API pattern in April, and they called it the advisor strategy. Sonnet or Haiku runs the agent loop, and it only pings Opus if it can't solve the problem on its own, and the numbers they publish are promising. Haiku with an Opus as an advisor jumped from 19.7 to 41.2% on a browser research benchmark, while costing 85% less. Anthropic's version still uses Sonnet or Haiku as the executor, but I expect that we'll be able to replace these executors with local models and drop the cost dramatically. But the cost is only one piece. There's also privacy. Every email and every document your agent touches is leaving your machine right now. Local open-weight models with permissive licenses is something you own 100%, and with them you actually get to choose whether your data leaves your computer or not. So the Linux of LMs is here. It's on the rise, and for the first time since the cloud took the lead, the curve compounds in your favor. It's a good time to start experimenting with local AI. With that, thanks a lot for watching. Vielen Dank für das Zuschauen. Благодаря и следващия път.